I think now we are starting. So good morning all. It's very good morning that we are joined today to discuss bio to bioenergy. I think that is a need of the hour because now because of COVID, there are many unemployment is happening in rural and village areas, and bio waste or the biomass aggregation, collection, and that converting it into bioenergy could be a very good option to give a employment to these all unemployed people, as well as it will be a very good option to replace our import or the to sub, to make India energy sufficient or the energy self-reliant. Just I was reading before on 8 June there was some news that our crude oil import is around 4.14 million barrels per day. So and total value of the year is around 125 billion dollars, and quantity is around 228 million metric ton of crude oil. So this is just for an oil. So other than this oil, there are gaseous fuels are imported. There are other energy products which are we are importing. So I think this is a very good employment opportunity sector, as well as it's very good sector which will be giving us a, a foreign currency. It will stop our currency to go in foreign lands, and as well as it will give us some boost to the biomass or the bio waste which is generated in the farming operation, and ultimately it will benefit to the farmers as well. I think our patron honorable Gadkari Saab is always mentioning about employment generation through this energy sector and energy cultivation at farmers field. So I think considering that direction from our patron, we are continuing with this journey, and that's the reason we are here today, and we are discussing now today, we are giving the online training to the interested stakeholders on bio waste to bioenergy, how that bio waste can be converted into bioenergy options. So we are covering almost 4 topics in today and tomorrow. That is, one is biogas, one is biodiesel, one is bioethanol, and last one is biomass or bioenergy, that is briquettes and pellets. So we have as a IFG, we have tried to involve almost all the industry leaders from this field. We have involved master trainers from Praj Industries. Praj Industry is a leading industry in bioethanol, biodiesel, biogas in the world, not only in country. And interestingly, they are our president and located in Pune, or in India only, and they are leading in around 75 countries, and they have put up around more than 750 plants in all around the world. So we have some interesting master trainer from this field, biogas, biodiesel, and bioethanol from Praj Industries, as well as here we are having one very unique master trainer from biomass into briquette or the bioenergy option, which is most of the time is neglected while discussing the bioenergy or the bioethanol or biodiesel. But there is a very much important sector, that is aggregation of biomass and converting that biomass into briquettes or the pellets or the required format by the industry or the biogas or biodiesel or bioethanol industry, because biomass or the bio waste is always a very voluminous material, and it is very difficult to transport to the factory from farmers field. So we need to have a kind of intermediaries, and that is I think only I have seen organized entity in the country which have established themselves in last 10-15 years in the country, and they are the only entity operating organized way in the sector, that is PRSPL, Punjab Renewable, and they are the only entity in the country. They have got funding from foreign investors in this field. So I think we have very good master trainers, mix of master trainers. And interestingly, now to inaugurate, we have Sri Ravi Boratkar from Maharashtra Economic Development. He is the president of Maharashtra Economic Development Council, as well as he is a chairman of Federation, which is very closely working with farmers of Central India, and they are the very good the largest organizer of agri exhibitions in the country since last 15 years. We have Shri Atul Mule, president from Praj Industries. Praj, as I discussed, Praj is a leader in this bioenergy sector, or the bioeconomy sector in the world. And we have another dignitaries today, that is Colonel Ahuja, Monish Ahuja, managing director and promoter of the PRSPL, and Sri Sanjay Ganju from Indian Federation of Green Energy. So I would like to start today's inauguration session with Sri Ravi Boratkarji. So Ravi Boratkarji.
Yeah. Thanks, Sandeep.
Yeah.
First of all, a warm greetings from AgriVision Foundation and Maharashtra Economic Development Council. All, and particularly my greetings to IFGE, which right from inception has been very consistently working on this area, that is green energy, bioenergy. Friends, as Sandeep just now mentioned, we have a wonderful faculty today, and I'm happy to see that even Mr. Colonel Ahuja is with us, and of course Sandeep, Mr. Sanjay Ganju is also with us for this master class or training session today, which will, I think, is for 2 days. So friends, as we all know, that India is one of the biggest economies with growing population, and with a huge capacity, big capacities of field and plantation biomass, industrial biomass, forest biomass, that is waste and aquatic biomass. But we also have a growing need for energy, maybe because of our economic growth or urbanization, or also with per capita consumption, which is significantly. And we also have the challenge of, as Sandeep also mentioned, about very dependence on imports of the fossil fuel. Therefore, it's quite logical that we look forward to some good option. And during this, bioenergy comes as a very cheaper and greener source of power to meet this growing energy demand. And I think that's why even the government of India has a target that by year 2022, government of India wants that 175 gigawatt of renewable installed power capacity, and of which I think, if I'm not wrong, 10 gigawatts of installed bioenergy capacity. But having said so, we also have is the fact that bioenergy is still very underutilized or underexplored sector in India, and there are a lot of challenges. And this maybe this 2 days interaction will help us. How can we accelerate and how efficiently we can get to our targets of having cleaner this bioenergy, maybe through biogas, biodiesel, or bioethanol, or biomass briquettes and pellets. So I think these 2 days will give a very good understanding to all the attendees, to all the entrepreneurs, for better utilization or even better energy management of their requirement. So I think instead of talking more about this, I will like to conclude that it's a very good initiative, and it's a very timely effort by IFGE, and this with the quality of the faculty we have today, I'm sure it's going to help immensely to all the attendees who are with us today. So I wish a good understanding about the bioenergy sector, and I wish you all the best. Thank you.
Thank you, Raviji, for your kind support and kind word for today's training, today and tomorrow's training. It is very much appreciated to get the support from AgriVision Foundation and MEDC to organize this training. Now I would like to move ahead with next dignitary today, Colonel Monish Ahuja. I think Mr. Atul Mule is struggling to get to join today's session. So I am moving to next dignitary, Colonel Ahuja.
Thank you so much. I hope I'm audible, Sandeep ji.
Yeah, you're audible, sir.
Thank you so much for inviting Punjab Renewable Energy Systems Private Limited and inviting me for this inaugural session. While you did mention about what we do, and thank you for the benevolent introduction. Yes, we do work with agri residue and focused working with agri residue which the farmers do not have any economic value for, and the farmers burn it or leave it in the fields, and it is a problem for the disposal of this agri residue after the harvest of the crop. So uniquely, we work in Presswell around supporting the farmer community with bringing this agri residue out of the field and to be able to create a commodity value and an economic value for this agriculture residue in the forward integration of energy streams. And this today is bioenergy and has multiple uses which can be done with this agri residue. Like rightly said, it is a resource which is from the agriculture sector, hence rural. And the resource mapping in India gives numbers of 100 million metric tons of this agri residue being available, and which is being burnt or destroyed or not being utilized for our economic value from the agriculture field. So what we have been able to do in Presswell is showcase across different types of farm agri residue, taking it to multiple energy value streams. And that is what in this unique training program which has been conducted is being conducted by IFGE and AgroVision Foundation. We are partnering to bring one element of it, which is from agri residue to briquettes or pellets, and how in rural India this can be taken up, because there is quite a big demand for both these briquettes and pellets today in the Indian market. What it also does is you are replacing fossil fuel, and hence you are bringing a better environment value to utilizing these agri residues. Uh, just to give a slight more forward integration brief, so what industries or technology providers like Praj are being able to do is utilize these agri residues for generation of fossil fuels, and fossil fuels both in gaseous and liquid forms. So there is compressed biogas, there is renewable natural gas. So you can replace CNG and LPG, which comes from the fossil routes. Then there are technologies to do higher value liquid fuels like ethanol. You can do drop-in fuels where direct petrol, diesel, aviation fuel, utilizing these biomass. So where the Indian economy is being directed by the government to become self-sufficient, so Atmanirbhar, uh, to be able to create an ecosystem where the Annadata becomes the Urja Data. So the farmer becomes the provider of the energy. And also with the huge reverse migration which we have seen from the cities to rural India, there is skilled, semi-skilled manpower and resource available in rural India. What is needed is to be able to take suitable industries to rural India, it could be micro, small, medium, and large industries, and to be able to create that job employment and opportunity in a sustainable and a clean green manner in rural India. And I think what we are going to talk about over the next 2 days is going to be how the industries that we would represent or bring to the forum is how this exactly meets the objectives being set forward by Government of India, and also meets the objectives of the sustainable development goals that we as a country have agreed to and earmarked upon. Uh, See, any such activity has to be financially viable as an alternative for it to work, and for industry or for the consumer to be able to realize it and have a market for it. And what currently is the benchmark is, because it's the start of the industry, it's a phase where the biofuel industry is now picking up. The requirement is for support from government to be able to give the initial thrust for the bioenergy or biofuel industry, like was given for the solar or for the wind industry. And government did give this support a decade back, and today we have seen that by the market sheer market dynamics itself, the price points of electricity from solar and wind have come to the 3 rupee or sub 3 rupee range. So what we also expect in the bioenergy segment is the initial support and hand holding from government side, maybe for the first 2, 3, 4 years, and then let the market decide and shift towards lowering the costs of this bioenergy. Ultimately, we as a consumer will be paying for it. So having said that, over the next 2 days, as per the schedule, Prespel would be bringing to the forum one element of it where we aggregate these agricultural residues and convert it to briquettes, which is the green coal, and then we market and sell this green coal as a commodity to multiple industries pan India. And here is an opportunity where rural entrepreneurship can come up with not a very high requirement of a skill set. So between a unskilled and a semi-skilled rural worker, such modular industries can be set up, and then the true transition of Annadata se Urja Data, where you will bring this form of energy from rural India to industries in cities. And that is exactly what we are doing as one of our business segments. And currently, Prespel does between 400 to 500 metric tons of briquettes per day. And in the next year's time, we are on the path to almost double this capacity. So we are establishing new projects on a pan-India basis in Punjab, Haryana, Maharashtra, Karnataka. We are also looking at newer areas in Rajasthan, Madhya Pradesh. So there is a huge scope. I'll just take a couple of minutes more to announce and inform about a program which Prespel runs, which is the Channel Partner Program. So if somebody in rural India wants to establish a briquetting plant, a briquetting unit, and does not know how to do it, but has the intent to become an entrepreneur or work for themselves to set up this micro or small industry, then Prespel is willing to support them as a channel partner. And this channel partner, we help with establishment of the project. We help them with training to run such a briquetting unit and project. And what we uniquely give them is support for finance through our banking partners, and also 100% product offtake. So the channel partner need not have to worry as to where they are going to sell this briquette. Prespel provides that market as well. And hence, we are creating these channel partners across India where they are able to run these industries, and in the delta of the profit, there is a share between the channel partner and Prespel. And the larger part of the share is with the channel partner. So this is a unique program which we are running, and currently we have about 15 channel partners who have got onboarded with Prespel, and the banking support for these channel partners through finance institutions, formal finance institutions like State Bank of India and NBFCs is now available to them in rural India. So we have been able to create this ecosystem, and I think this is one of the ways that people who are interested to do this in rural parts of the country can find a mechanism to start. Otherwise, there were challenges about how to set up the industry, where to get the banking support or finance from, how to do the paperwork, even after they do everything, how to run the industry and where to sell the product. So all of this uniquely as one single solution we have brought. So Colonel Rohit Dev, who is the Chief Operating Officer of Prespel, and I've seen that he has shared his details as well in the chat column, is part of this two-day program. He will also be online in this forum tomorrow. And people who are interested can contact us. We'll be happy to share more details and participate in a proactive manner in developing this across India. With that, I thank Agrovision Foundation, IFGE, Praj, who have come together along with Prespel on this platform. A very unique concept, and my compliments to Sanjay Ganjuji, Sandeep Thangji, and the team, and my good wishes for this particular two-day training program. My coordinates also I have taken the liberty to share in the chat box which is there. So anybody who wants to contact us or needs some information, please feel free to write to us or contact us on WhatsApp or phone. And definitely we would like to engage and have a good discussion ahead. Thank you so much.
Okay. Thank you very much, Monish ji. It's very wonderful introduction of the sector. You have given right from availability of surplus biomass or the collectible biomass in the field, that is around 5 million metric ton, and your support to this sector through channel partnering and 100% uptake from channel partners, and you're already touched upon more than 500 metric ton of briquettes per day and already more than 15 channel partners. So I think it's very interesting to know for the participant that there is a partner who is ready to uptake 100% and ready to support right from soft skill to establish the industry in the rural sector, rural area, and 100% buyback with complete technical know-how and complete support. Thanks, thank you very much, Monish ji, for your support and partnering with us or with IFG for this today and tomorrow's training. Yes, definitely, your colleague Rohit ji will be presenting tomorrow very extensively on the details of the briquetting industry. I think still we are unable to get Atul Muleji on board. So I will move ahead to next our dignitary, Sri Sanjay Ganjuji, who is the Director General of Indian Federation of Green Energy and Chairman of Bhaskar Foundation. So who is a pioneer, or you can say old fatherly figure in skill development in the country. So, and this is a training program, it's a kind of skill development in the sector. So I think we are very much honored to host him as one of the today's dignitary in the program. So I would like to go towards Sanjay Ganjuji. Sanjay Ganjuji, your concluding remarks for the today's inaugural session. Sanjay Ganjuji. Sanjay ji. Hello. I'm audible? Hello. Hello. I'm audible.
Yes, you are
Hello.
audible. You are hello.
Unmute.
You are audible, sir.
Yeah.
I'm just
I
unmute.
Okay. Okay. Yes, Sanjay ji.
admin
Yeah.
guests
Please.
this training program, which I think is unique and one of the few ones which I have seen that from bio waste to bioenergy, a training program has been conducted. So we took a lead. We thought that we have done a lot of programs, webinars on policy issues, business aspects of it. But I think we need to now go into the actual brass tacks. And what are the technological issues? What are the, how the operations are, conducted? So we are grateful to my dear friend, Colonel Monish Ahuja ji, and I'm sure he will become one of the leading lights in converting this green gold or whatever fuel we are calling biomass we are into bioenergy. So I think he will become one of the leaders in this country. The invested into it, the kind of passion he is having, and I also thank our Praj Industries, our president, Mr. Pramod Chaudhary ji is from Praj Industries. He's the chairman of Praj Industries, and his colleagues are always a great support. Praj has always been supporting initiatives of IFGE. So, I think it will be a great session. We have very strong resource persons from both these organizations. They are actually on the ground working. Sorry, I think there was a light in my, behind this window. So I will not take much time. I will not waste your time. Get the knowledge and take some takeaways from this conference. मैं सबको फिर से आभार प्रकट करता हूँ, बहुत बहुत धन्यवाद करता हूँ कि इस कार्यक्रम में आप हमारे साथ ज्वाइन किए, आप इसका पूरा लाभ उठाएं और कुछ सवाल इन पर्सन्स जितने भी हैं इसमें उनसे आप पूछ सकते हैं. उसके बाद भी आपके कुछ अगर डाउट्स हों तो आप जरूर आईएफजी को संपर्क करें. संदीप मेरे जो डायरेक्टर है आईएफजी के, मेरे रमन जो डिप्टी डायरेक्टर हैं आईएफजी के, आप उनसे संपर्क कर सकते हैं, मेल भेज सकते हैं. जो आपको डाउट्स होंगे, आई एम श्योर वी विल clear. So I wish this training program a great success. And Sandeep, you please carry on with other speakers. I will be continuing with this for time, and if time permits, I will definitely be with you for the entire program. Otherwise, I will if something I may have to leave. So I again welcome you and request Sandeep to take over. Thank you.
Thank you very much, Sanjay ji. I think we are on time. Yes, we miss Atul Mule ji from Praj, but whenever he joins back, we'll hear from him. I think now we'll be moving now straight away to the main part of this training program, that is training, online training for bio waste to bioenergy. So we'll be straight away going to Basavaraj ji from Praj Industry. So he will be giving us training on basically biomass or the bio waste to biogas. So last 19 or 20 years he is working in this organic waste conversion into biogas, and he has been involved with many processing industries like distilleries and starch, paper, and MSW to biogas industry since last 20 years with Praj, and now he is very much involved in this biogas or the CBG, the compressed biogas, which will be used in vehicles or the industrial application, and which will be produced from this any organic waste. So, and he is working on shop floor So I think he will be the very good trainer for today's session. So I'm straight away going to Basavaraj ji from Praj Industry. Basavaraj ji, please. Yeah, Basavaraj ji.
Yeah. Yes, sir. Thank you.
Yeah.
Thank you very much to IFGE for giving us this opportunity to present about a complete gamut on biofuels per se. So I'll be first covering on biogas part, and my colleague Mr. S.P. Singh will be touching on biodiesel, and tomorrow Mr. Mahesh Kulkarni will be talking on bioethanol. Thank you very much, IFG, and we have seen IFG taking a lot of initiatives in taking this drive forward of Atmanirbhar Bharat on in terms of energy. So I'll just start the topic as the organizers had told me to talk on the biogas part, and then I'll take you through the biogas generation and all. So in the index, I'll be talking on about Praj Industries and introduction of biogas. And my screen is you all able to view my screen, right?
Yes, you're very much audible, and we can see your screen.
Thank you very much for the confirmation. And then echo, I believe. There is some echo, I believe. So
Yes. Yeah, there is some echo from your side. Maybe I think you have to mute the other colleague from the chamber.
Hello.
Yeah.
Hello.
You have to mute others from the chamber.
The other gentleman already muted his computer. Give me a moment.
Please go ahead.
Hello. So, in a couple of slides, I'll talk about Praj Industries, and then entering to the subject, what is biogas plant, what are the sources required, and different types of biogas digester per se. The type of reactors are available for small scale, large scale, and for the industrial application. And what are the selection criteria, how we should be selecting, and introduction to once the biogas is generated, then it will be used as a gaseous fuel called CBG or bio-CNG, and the very ambitious program of Government of India, Satat program, I'll be touching upon that, and some case studies and troubleshooting, so how input output looks like for a typical capacity. So with this, just information, corporate information about Praj Industries. It has started in 1983 by our promoter chairman, Dr. Pramod Chaudhary, and then since then he had a vision that we should be backed up by R&D center. So since then we have a R&D in-house supported to all the technologies, and later on we had IPO in 1994, and then we ventured into Southeast Asian markets like Thailand, Philippines, Singapore, and all. And then gradually we moved to American market. Then we set up Praj Matrix R&D centers, and then scale up of bioethanol. So we were there in the 1G bioethanol. So 1G bioethanol, when I say the ethanol generated from the sugary starchy feedstock. And then in 2008 till 2014, we had scaled up second generation bioethanol, means which is biomass based or a cellulosic, lignocellulosic based bioethanol technology. And then we entered to high purity segment through inorganic growth, acquiring Vanilla Systems. Then we have had a first integrated 2G biorefinery. When we have entered in 2017 onwards, and then we have gas, RNG, renewable natural gas, which we call in other terms compressed. So yes. So at a glance, we have more than 750 references. In that, we do have around 50 to 60 biogas plants as well, which are supplied to ethanol industry, which could be molasses-based or a grain-based distillery. We have presence in 75 countries. We have 1,200 employees. We have more than 90 researchers who are supporting the technology development. So globally, the ethanol contribution, the ethanol production contribution comes about 8%. We are 35 glorious years. So this is a little background, and our business lines, we are into bioenergy sector, where the renewable natural gas or the biogas falls in this bioenergy sector. And then, as I said, high purity segment, which catering to pharma and biotechnology business. And we have engineering business, where critical process equipment, effluent treatment division, which is catering other than distillery. We have brewery division and the R&D center. So as I said, the matrix is backbone of our technology. So we have the major focus in our R&D center is on bioprocessing technology, and this biogas is also part of that. That's why I'm giving little background, so from where we are coming. And we have developed our the proprietary consortia in pre-treating the raw materials and the processing of to increase the biogas generation in the anaerobic digesters. So we have a very strong project management team to support the large-scale projects executions in Argentina, US. We have executed projects in US. The largest ethanol plant we have executed in UK, so which is 1,200 KLPD ethanol plant for Vivargo. So these are some glimpses. With all this, what is our drive, and we want to contribute to biomobility for the country's drive. So we biomobility which will decarbonize through circular economy. So as we know, the major demand of the GHG emissions coming from the transportation sector, and this stubble burning is causing a lot of issues in northern part of India. To how to cater and what alternative solutions we have wherein we can generate energy out of it. It could be biogas or bio-CNG or ethanol, and there are our colleagues, Mr. Ahujaji already mentioned, briquettes are there. So there are a lot of other solutions based on the permutation combinations available and the availability of raw material. So we have to offer the solution. So biomobility is based on transportation helping carbon footprint. With this background, I would like to enter into the subject. So just as an introduction of biogas, what is biogas basically? Biogas is, as a definition, when we degrade any organic matter in absence of oxygen, it releases some gas. So that gas is called biogas, and this reaction happens in anaerobic condition. So the gas, whatever the organic matter which can putrefy, which can degrade, can be digested through these biodigestion. Though it looks very simple, I mean, we have all seen this biogas generated in our villages through a gobar gas plant. It is similar to that. I'll touch from there and I'll come to the industry scale biogas plants. So coming next, what is the composition of this biogas plant? The main portion of this biogas would be methane, and the percentage can vary from 50 to 70 depending on the raw material what we feed to the digester. And it has carbon dioxide, hydrogen sulfide, ammonia, water, nitrogen, everything. The gas, whatever comes, will be the water which comes with biogas will be in a saturated form. Based on the temperature and the pressure conditions, it will carry the moisture along with it. And the hydrogen sulfur content can vary based on the sulfur load which is going to the digester. So, I mean, how this biogas plant helps in terms of reducing, why this biogas plant should be. So in the first place, this is solving the problem of treating when it comes to industry grade. If we have to treat any organic effluent per se, if it is having a COD/BOD ratio of 0.5, that can be treated through biomethanation. Earlier, the biogas coming into picture, it used to be treated through an aerobic route. This aerobic route consumes a lot of energy. And if I treat the same waste, okay, and for that matter, any organic waste, it could be solid or liquid, it needs a lot of energy when I have to treat it through aerobic route. So similarly, if I treat this through anaerobic route, I need a very minimum energy input to the system, wherein it will generate one more renewable energy called biogas, which is of more than 50% methane content in it. So which can be used further for any of the applications. So there are different applications, we will look into it. And apart from that, it will be generating two more co-products, which is organic manure in the form of solid and the liquid organic manure. So in a way, the biogas plant gives three outputs. One is gas and another two. One is the solid manure and the liquid manure. So what are the sources of biogas? As I said, the organic waste from commercial or industrial establishments could be food waste, market waste, and the other vegetable waste, mandi waste, and all those things will come in this category. And there is another source like landfill. As the municipal solid waste, one of the way of treating this municipal solid waste is through landfill gas. So in this landfill gas is also an anaerobic process, which is all this organic waste is filled in the land and it is covered from the top. And after a year or so, the gas is extracted from that landfill site, and it contains, along with methane, it contains other gases also. One point I would like to highlight here is it will have a low methane concentration. It will have other impure gases like siloxanes, and it could have syngas and all those things. It needs more level of purification to consume it, or rather to utilize it in other applications. And one more source of raw material could be sewage waste, when we treat sewage effluent, it generates a lot of aerobic sludge, and which is a very potential source for the biogas generation. So in STP, whatever we have, just to give a ballpark idea, so the sewage treatment plant of 100 MLD sewage treatment plant can generate about 200 meter cube of a gas. So you can imagine there are large scale sewage plants in the metros in Mumbai, Pune, and Delhi, Kolkata, and Chennai. So all these gas, this practice is already there in few of the STPs in Chennai, where the biogas generated from this sewage sludge is used to produce the electricity. So I have witnessed these plants, I have seen these are all working. It's a good source of raw material, barring some issues like the yields, the concentration, and the purification methods of the technology used. There are some shortfalls, but per se what I would like to tell to this forum is these are the good raw materials which can be used. And then anyway, the major problem what we are talking about, the stubble burning and the agricultural residue, which has it has a very good potential. I'll be touching on that part as well. So the major source, the major potential source of biogas could be sugar mills, distillery, and the agri residues, and the secondary potential which is coming from the industry. So as we all are industry people, we need to see how the scale of economy, how the project is made economically or self-sustained in terms of its revenues. So that's why I'm focusing our discussion towards industry. These are now coming to the topic of types of biogas plants. So these are fixed type of biogas plants which are available even today in the market, and these are the small scale plants which are operating, almost 40-50 years they are in operation. These are used in the rural area for producing the biogas from the raw material like maybe cattle dung or any other feeds. Mainly when it comes to villages, they use cattle dung, all the domestic waste they use to generate these biogas. So these are called fixed dome type, and there are a lot of MNRE is also giving some support on these domestic individual biogas plants, under decentralized model. There are some technologies called KVIC technology and all. But in broad sense, these are all not a very big size biogas plants, 100 meter cube or so. And the second one is a floating type biogas plant, where the gas holder will be floating on the substrate which is subjected for the degradation. So it is designed in such a way that the dome or the holder is only all the gas generated from the substrate. Here again, the substrate, mainly these kind of plants are used, these kind of reactors are used for food waste and the cattle manure and all. But whatever the gas generated is stored in the dome stored in the gas dome, and it has been designed in such a way that the gas is not allowed to escape from the reactor. So these are the plants which are available, and the next level of the industrial level reactors what is available in the market are, and we are also offering this technology, which is a flow reactor. These are available in both the operating conditions, maybe mesophilic or thermophilic operations, and some of the designs have the agitator inside the reactor, but in our process we don't use any agitation. We mix the substrate through the gas mixing, and it has a lot of advantage because the operating cost is very less in this case, and the important point is all kind of feedstock can be treated and it has a distinct advantage. Like I'll be talking on the reaction part. That time I'll cover that part, how the plug flow reactors are better compared to other conventional technologies. So one more technologies which is available for the offering are available in the market are CSTR reactors. In this kind of reactors, it is CSTR. When I say it is continuous stir type reactor, where the mixing or the agitation is done through the agitators. So in these agitators, there are a lot of options available. It could be completely submerged agitator, long axial mixers, which you can see in the photograph. It's a long axial mixer, tangential entry. There are a lot of permutation combinations. And I would like to say in the biogas digesters, very important criteria is there are three important parameters which you need to consider is your to pump well, heat well, and mix well. These are the three important elements in any biogas digester. So what are you pumping? Along with that, it is also important that what are we pumping, what substrate matter, how much total volatile solids are there, is it degradable, non-degradable, all those things are there. But per se, when I'm talking particularly on the digester, these are the three parameters which we need to focus. So what are the factors affecting the biogas generation? So as we all feel like, and the biogas plants are, we have seen it, I mean, from our childhood, it is a very simple process. But when we talk about the industrial plants with the economics around it, when we are investing, we need to do it properly. It has to be properly engineered biogas plant. It can't be just a reactor where I'll just subject some substrate and some gas will come. No, because we are investing in these reactors, and to have a complete, to establish this complete project, we are investing huge. So we need to consider a lot of factors while designing the reactor and when it comes to while operation as well. So the important parameters, like we need to have a right pH in the reactor. So when I say right pH, what is it? It should be in the range. It should not go below 6.8 and it should not go beyond 7.8. Why this pH is required? Because the generating bacteria, probably I would like to use this slide to explain this. The second, third and fourth phase of this reaction, I'll be talking a bit on phase 1, phase 2, but to give an example to illustrate the some technical issue. So these methanogens are active only, and these are very sensitive to pH. So if pH goes below 6.8, the methanogens will not be active. If these are not active, and the major focus of this entire process is to generate more methane. So if these consortia are not active or dormant, or if they die, as I said, they are very sensitive towards pH and temperature. So we need to maintain appropriate pH in the range of 7. This is the significance of pH and the substrate composition. As I said, if I subject some substrate which don't have degradability into it, so before offering or before any selecting any substrate, we need to do the BMP test of these substrates, and which we have this facility in our R&D center. And we check, though, let's say if any rice straw is there, but we bring those samples in our R&D center, and we check the BMP test of these reactors to assure what level of gas is possible to generate with this feedstock and what are the composition. As I said, temperature is another important parameter which we need to maintain. Why this temperature is, and I will be talking on this as well. This biogas reactors are as good as the as it is very similar to cow stomach. So all mammals temperature, body temperature is in the range of 38 degrees centigrade. So as I said, the biogas plant is very similar to cow stomach, and cow has 4 stomach. One is rumen, radiculum, humecum, and abdomecum. So these are the different stages of the parts in the stomach itself, and cow has an unique special digestive system, and the similar kind of operation happens in the biogas plant per se. So as I said, the reactor temperature needs to be maintained at 38 degrees centigrade. And the next point what I'm talking about is the working pressure of the digester. We should not have a very high pressures inside the reactor, because at higher pressure inside the biomethanation reactor will also inhibit the biomethanation process by affecting the consortia get affected, and we need to maintain volatile fatty acid level. This volatile fatty acid level could vary from substrate to substrate. What level of volatile fatty acids we need to maintain? If I am using rice straw, it could be different. If I am using distillery spent wash, it could be different. If I am using press mud, it could be different. If I am using food waste, it could be different. We need to establish these parameters in the lab before applying it to the commercial level. And then the appropriate retention time is very important parameter. And then coming to the reaction process, how the entire biomass or the organic fractions get converted to biogas. It has 4 distinct processes which is very much required to get very high concentrated methane in the biogas and the desired yield of the biogas based on per ton. In this distinctly, I would like to mention these reactions, like if I use a feedstocks like spent wash and all. Here, the phase 2 and phase 3 are very fast reaction. For that matter, even the phase 1 hydrolysis is also very fast. But whereas in the distillery spent wash also, the phase 3 to phase 4, genesis to methanogenesis, it is a slow reaction. But when I'm talking about this, the other feedstocks like biomass, press mud, and other food waste and all, these reaction, the first 1, 2, 3, these phases gets elaborated. It needs more time. That's the reason this has to be operated in 2 different operating conditions. And the very high probability when it comes to biomass based, if it is a Diglycerides, and when I say these rice straws and all, polysaccharide generating this propionic acids and all, which is very toxic to methanogen. So we need to do the proper analysis or what level of propionic acids are there. So we have established for particular feedstock some level of these acids should be maintained in the reactors. So based on that, we operate our plants. So, and with all these due considerations, still there are some issues around these kind of biogas plants. So what kind of problems we generally face in the biogas plants are gas yields gets dropped, okay, during the course of operation, and methane concentration drops, and there is a huge possibility of foam generation in the reactors. How we are catering those, and there is a possibility of pH getting dropped. So these are all the most probable causes. What we see is the, I mean, possible causes for this could be reduction in the feed to the reactor. We don't know. We are assuming that, let's say, 100 tons of rice straw is fed every day. But actually, if it is fed only 80 tons per day, then we tend to we tend to depend on the operators. So, but we need to keep a complete eye on the operational crew also in this, whether desired quantity of substrate is fed or not. When the methane concentration drops in the reactor, it could be possible reasons could be either the temperature drop, or the volatile fatty acid has been increased in the reactor, or is the reactor operating under high pressure. So all these parameters needs to be checked. That's the reason we operate our flow reactor at a very minimal pressure, and then and these kind of feedstocks, we have possibility of foam generation, scum generation is there, and these needs to be how to break these foams and scums. We should have a proper mechanism to it. And drop in pH could be many reasons, like temperatures, if a reactor is not in a healthy condition, and if reactor temperature is not maintained. If we are, sometimes it might also be possible that though the reactor system is designed for 100 tons, but the operators might be feeding it 120 tons, which is not, which the reactor will not be in a position to handle it. So as I said, it is, I mean, for a cow, we need to give a desired quantity and quality feed to get the desired milk. In a similar way, like the human beings, if we consume every day 2 chapatis, we can't consume next day 10 chapatis. So we need to give a appropriate or the designed quantity of feed substrate to the reactor. So how, I mean, I tried to, in this slide, I tried to simplify the reaction process, what is required and what is not required for the different feedstocks. So we are mainly focusing on, in this presentation, as I said, the industry level projects we are talking about. And when I say these feedstock like manure from any farm waste, the cattle manures for a big cow farms or the farms, it could be poultry litter and all. In this, we don't need a very elaborate pre-treatment, and also it can be just a slurry preparation. Appropriate level of total solids needs to be maintained, and then you can feed it to AD system, anaerobic digester. But when it comes to agriculture waste, it needs elaborative treatment, and even before that, we need to have a size reduction. So this is the major difference when it comes to farm waste and the agri residue. Even when it comes to agri processed waste, it could be sugar factory press mud and maybe other food processing industry waste. There we need to ensure whether the raw material, whatever is coming, is properly preserved, so that the total volatile matter, TVS, what we call, or the organic fraction which is present in the feedstock, it will not get decomposed on its own, and then slurry preparation, and then it subject to anaerobic reactor. So whatever the biogas generation, it will anyway go for the purification system, which is also one more critical component. I'll touch upon that also. So I tried to give the complete overview. How does it look like with a different feedstock? As I explained, three different feedstocks like farm waste, industrial waste, kitchen waste, and the agri waste. So it will, based on the feedstock, the level of pre-treatment varies, and then it will be subjected to flow reactor. And after that, it will have three products. As the main product would be the gas, and this gas we subject it to compressed biogas. Before subjecting it to compressor, we need to purify to bring down the impurities present in the biogas. As I said, the biogas has a composition of about 55 to 60%, or maybe it could be higher as well. We need to bring this to 90, 95, 96% purity level, and then we can compress it, and it can be used for different applications for transport fuel or maybe gaseous fuel. And then the second application of it could be CHP process, combined heat and power. I can in this level, we don't need a very elaborative gas purification system, but we need to desulfurize the gas. As I said in my previous slides, it will have a H2S content present in that biogas. We need to remove that part, which we call desulfurization, and then we need to bring it to the level depending on different engine makes, says different power output. H2S level to the engine, and these engines efficiency could vary anything between 35 to 44%, and we can use this for and the waste heat recovery can be used it for steam generation or any other application. And the other part of other co-product which is coming out of the biomethanation process is subjected to solid liquid separation, where slurry which comes out of the reactor is subjected to solid liquid separation, and then it goes to organic manure. And recently we got the fermented organic manure, and it is in certified under FCO also, and it is a very good welcoming news for this industry or this biogas sector per se. And the liquid manure, whatever is coming, can also be further used as a liquid fertilizer. As I said, four distinct components required while selecting. We need to consider while selecting the biogas plants what kind of substrate I am using, whether it is the right quality, and the availability of logistics. So PRSPL will be explaining more on these logistic parts when I have to collect this rice straw and all from the distinct, at what level certain radius only we can consider, otherwise the transportation cost will increase. What quantity of substrate I am bringing, type of, and next selection criteria would be what kind of reactors I am using. As I already mentioned, all the different types of reactors has its own advantages and limitations. And proper sizing of the reactor, undersized or should not be oversized also, to looking at the economics. And what energy output coming. So per ton of TBS reduction, are we getting right quantity of biogas. So then only it is called as a properly engineered solution to this kind of reactors or this kind of projects. And along with that, along with engineering, the microbial process also plays a very vital role in this. And then next, the last and very important part is the investment and the benefit, cost benefit analysis. What kind of project IRR we have, what kind of paybacks we have, we need to look into these aspects as well. So as I said, the different applications of gas, we can generate direct electricity through IC engines, and we have a transport fuel which can be gas can be a replacement to CNG. In upcoming slides, I'll be touching upon how the CBG, the energy value and the CNG are similar, or rather how there is a synergy between these two fuels. One is the non-conventional route of generating this fuel, and another is a conventional route. So this is a renewable source, and CNG is a non-renewable source. And this biogas can be also used for the steam generations in replacing bagasse, coal, diesel, and HFO in the industry, which is the present practices. And we have almost more than 50 biogas plants working. So from the distillery, so they are all using it for the replacement of bagasse, coal, and all other fuels. And the co-product, as we have already discussed on this part, so I'll just go to next slide. So what is biogas, and what are the different synonyms of CBGs? So as I said, the CBG composition should be, methane composition in the CBG should be more than 90%, as per IS 16087 2016. And the initial gas, I said, based on the raw material, it could be anything between 35 to 65%. This biogas, as I said, you can see the diagram here. We are we are stripping out all these impurities: carbon dioxide, moisture level, hydrogen sulfide, ammonia, nitrogen. So we are only interested in this methane. So once we strip out all the impurities, then that is called as CBG, or the biomethane, or the purified biogas. So as I said, in Western countries, it is called as renewable natural gas, especially in US and all, and biomethane in Europe, and compressed methane and green gas and compressed biogas or bio-CNG in India. So as I said, how the composition of CNG and CBG are differing. So the composition of CNG and CBG are, the methane concentration in both the cases are 90% only, as per the 90 aspects mentioned. But whereas in case of CNG, we have other hydrocarbons. Okay, so but whereas in case of CBG, we don't have any other hydrocarbons, and there is a cap of CO2, not more than 4%. So as I don't have other impurities of nitrogen, CO2, and oxygen all put together should not be more than 10%. So in that case, if I don't have nitrogen and other impurities, so which is maybe 0.5 milligram per meter cube and all when it comes to oxygen and all. So it happens, I mean, eventually I need to increase the concentration of methane to 95-96%. So it all depends on the substrate what I am using and what is the composition of biogas I am getting. So this we discussed. I said, when it comes, as we discussed about till now, we discussed about the biogas plants, what are the parameters which we need to keep in mind in operating the plant. And once the biogas is generated, how I am going to purify it to get to CBG grade quality. So it needs, foolproof desulfurization process. As we all understand, all our industry people, hydrogen sulfide is very corrosive gas, and which needs to be removed. We need to bring it to 20 milligram per liter. So we should have a very rugged desulfurization process, and then CO2 removal system and the moisture removal system. There are three distinct unit operations required to get the desired CBG. So, as I said, we are in collaboration with the DOE Inc. United States of America. So we are offering a plug flow reactor. What are the USPs of plug flow reactor? As I mentioned earlier, here we can achieve acidification, hydrolysis and acidification in the first part of this reactor. This is like a plug flow. This is like a rectangular reactor. You can see the flow path. The substrate is moving like this and then taking a U-turn and it is going out. So in first part, we are maintaining different operating conditions, and when it comes to stage 2, we are maintaining different operating conditions. And one more important point in plug flow reactor, and which we can't do in CSTR, is we can maintain SR. In case of plug flow reactor, what we are offering, SRT is equal to HRT. What is SRT? SRT is solid retention time. Solid retention time is equal to hydraulic retention time. What are solids? So solids which are coming along with the feed substrate or the total solids, it will have a similar retention time, because there is no channeling or short circuiting is possible in this reactor. So along with this liquid substrate, only the solid has to go out. That's the reason we have same SRT and HRT in case of plug flow reactor, which is not possible in case of conventional reactors. So as I said, once this gas is generated, as I mentioned, we should have appropriate desulfurization process. Based on the H2S levels in the biogas, we offer different kinds of desulfurization process. This is ion chelating agent based desulfurization process, where we are using ion chelating agent as a catalyst to remove the sulfur which is present in the form of H2S, which will be converted to solid. You can see the sulfur is coming out. Is coming out to this filter press, and the liquid, the chemical, the ion chelating agent is taken back for the regeneration, and it will be recycled. It will be recycled back after regeneration. It will be recycled back to the main reactors for further desulfurization of the raw biogas. So advantage of this is very minimal quantity of sulfur chemical required in this process. It is a chemically self-generative in the process itself. So we need to top up any small quantity of desulfurization. We do have alkali-based scrubbing system, and in that, based on the H2S levels, if the chemical requirement is very less, then we offer those technology also. So as I said, after desulfurization, second important part is we have to remove the CO2 from the biogas. So we do have in our technology basket, we offer both chilled water scrubbing process and also the membrane scrubbing process. So both have its own advantages and limitations. So in the chilled water process, the raw biogas after desulfurization is compressed up to 7 to 8 bar, and then it is subjected to a stripping column, wherein the chilled water will absorb this CO2, and the pure methane of more than 90% will come out, and it will go to the drying system, which is molecular sieve based, and then the moisture is taken out, and we will be in a position to achieve the IS specs. And what happens to the chilled water which I used for the scrubbing process? We are regenerating it back through the regeneration system. It is just by once we flash these CO2 rich water, it liberates the CO2 out, and the water can be reused. So with all these technological advantages, with the R&D backend, what we are bringing to the table, just for sake, I have this comparison I have made it especially for the sugar factory press mud. We have a proprietary microbial process, and we have the advanced reactor. With that, we can produce around 51 kg per ton of press mud. In case of conventional, it is only 40 kg per Cbg per ton of Cbg. And in this, as I said, we have a two-stage reaction possible in case of PFR. In case of CSTR, it is a single-stage reaction, and the methane slippage is up to 3%. And in case of other technologies, maybe if it could be molecule based, PSA based, and all, there the slippage could be up to 10%. And the FCO approved NOCA certified organic manure also is available. And we have a scale-up expertise. The biggest plant what we have designed is about 115,000 nm³ per day. So if I have to talk in terms of Cbg, it can generate about 35 to 40 tons of Cbg. So we have learned with our experience of distillery spent wash business. These are the 4 key unit operations which I mentioned. Because of that, we would be able to get the highest yield, better gas purification system, and high quality organic manure NOCA certified. So these are the some of the credentials where we got the NOCA certified manure certificates and all. So to take a typical case study, if I take a sugar factory of 8,000 TTD sugar factory, and if it operates at 190, 200 days, we'll generate about 60,000 tons of fresh mud. And we can have about 200 TPD of press mud available to have the round the year operation. So the typical composition of press mud is about 25 to 30%. In that, about 80% is volatile matter, and the remaining is moisture. So in all, what expected outputs with the 200 TPD of press mud, it would give about 10 tons of Cbg. That will give fertilizer, solid fertilizer, about 40 tons per day, and liquid manure in the range of 100 m³ per day. If the similar feedstock, if I want to go for biopower case, so I would be able to generate about 2.5 megawatt of power with this kind of plant, which I mentioned the capacity is about 200 tons per day process. So this is how the entire value enhancement, and just to give photographical view how each unit operations looks like. This is the press mud, and then this is the plug flow reactor, which the photo which you can see, it is underground, and it can also be above ground based on the soil conditions we decide. And why underground is preferred is the temperature. As I said, the maintaining the temperature of the reactor is very critical and very important. So in the fluctuation below 1 meter or below 2 meter, the temperature variation of the reactor is very minimal. That's the reason we should have underground reactors. And then desulfurization and desulfurization through ion chelating agent or alkali-based rubber, and then the CO2 removal system, compressor, and it can be used for transport fuel or industrial application. So how the value enhancement of press mud can happen? Let's say if the sugar factory presently is selling the press mud as a manure to the farmers at the rate of 150 to 200. In many of the cases, in many of the sugar factories are giving it to their own farmers as they are buying a sugar cane from them. So, but still I have considered some nominal value for the press mud. If you convert this to CBG or CNG through the advanced technologies available, so you can fetch about 3,000 rupees per day. This is the value enhancement of per ton of press mud can happen. So, this is our pilot, followed by demonstration level what we have done at Srinath Maskoba Sakar Karkhana, which is near to our near to Pune. And just to show, we have achieved up to 98% methane in that. And and these are the few reference large scale reference plant which I was referring to. So we have built a 22,000 meter cube reactor for the Triveni engineers who are well known in the industry for their turbines and all. And the Bajaj Hindustan Kinoni, the one of the leaders in the sugar belt in northern India. We have 3 projects with them. And then these are gradations where biogas to power, and one we have done in Goa where we have given the gas purification system, and this is under execution, Maruti Shikari. And other references is we are coming up with a big large scale press mud to CBG project with India Potash in UP, so which is under commission and will be very soon commissioned. And as I mentioned, we have our own demonstration plant from where we have developed technology from our R&D level. Then we go a very pragmatic approach we take as an organization. First, we develop any processor technology at a pilot, then bench level, then demonstration level, and then to the commercial level. The similar kind of approach we are taking here also. And then we, as I said, the gas purification plants in a couple of other locations. So, as we said, the Satat program, and in that we all understand what is the total feedstock potential available, which is 60 million metric tons of press mud is available. The bifurcation looks like this. The potential is 62 million metric tons. In that, agri residue, MSW, and STP and cattle dung are the major contributors. But however, MSW and cattle manure, these are all not raw material available at one single location. It is all scattered. So in that way, and sugar factory press mud is an organized and assured raw material available at one location. So, so as I said, what are the biomobility pillars? Make in India, Swachh Bharat Abhiyan, doubling farmer income. Rice straw is burnt in the farms, which is not giving any value or the revenue to the farmers. If rice straw based CBG plants are, if we stop the stubble burning and if we start making biogas from this and then to CBG, it will farmers' income will be doubled. And energy self-reliant, which is the major drive government of India is taking, this fits into it. If you see, I mean, a lot of push on this to secure the energy requirement of the India. So we need to, as an industry, we need to encourage this opportunity to take this to next level. And the strategic policies is to reduce the crude oil import by 10%, national biofuel policy, and the sustainable alternative towards affordable transportation fuel. So out of this, there are more than 500 plus UIs have been expression of interest have been shown by the industries under Satat program, and out of them, few of them are really coming on the ground. There are some other issues like financial closures of those related to these projects, and assured take or pay requirement, like if the CBG is produced, the oil company should have an take or pay kind of agreement. So all these things are there, but even then there is light at the end of the tunnel. So these days no one was talking about, till now no one was talking about this industry, and there is an opportunity to generate and opportunity to convert this biogas to CBG. So there will be some hiccups in this other programs, but it is a good move, and the federations like IFGE and all have to take this forward to debottleneck the problems whatever Satat program has. In that, they are assuring 46 rupees of sales price of the CBG, and they are also agreeing to the long-term buying of CBG under this program. And this is how the producer will make the biogas, and then he will transport it to OMC and through a dispensing station, and it will be sold under their brand name. So with this, these are the long-term prices which Indian Oil is assuring. And the biogas plant is coming under white category or the green category. Some of the states are very progressive. They have taken steps and they have already declared these biogas plants under white category. So along with that, there are some central financial assistance. Maybe MNRE is giving subsidy to these projects. So for a typical 4-ton CBG production, sorry, 4.8-ton CBG production, you will get about 4 CR as a capital subsidy. Okay, so which is equivalent to 1 megawatt, and the upper cap is about 10 crore rupees per project. And if it is a distillery based, where the biogas plant is already available already in the premise itself, in the factory itself. So, and if they go for a gas purification and compressing and filling, then in that case, MNRE will be giving around 3 crore subsidy. So, with this, I would like to conclude my presentation, and we will be happy to answer if you have any question. Maybe I think as per the schedule from the organizers, there will be question answer sessions after one more presentation.
Yes. Thank you, Basavarajji. I think it's very good presentation about biogas and biogas sector. How we can move ahead with the available biomass and available press mud with sugar industry. There is hardly any value to that press mud available with sugar industry. So, but you can move that biomass into press mud into biogas. It will fetch you around more than 3,000 rupees per ton. So definitely it's a value addition to that waste of the sugar industry. Yes, I think we would like to take question related to CBG immediately, so that people will be. I mean, is there any specific slide they want to see again, or anything specific to slide? They will come back to you. So I think I would like to go for the immediate question on this topic, that CBG. So maybe anyone is interested to ask the question can raise his hand using the option in that participant options. There is a right hand on right hand. There is when you click that participant, you will get raise the hand option. So I am opening up that raise the hand option for all the participant. That yes, if anybody is interested, he can ask the question related to anything. Now we have learned from Basavarajji on biogas.
Yeah, I think I could see questions in the chat box. Somebody has asked how the sulfur is discharged from the plant and in what form. So, as I said, the sulfur would be discharged in the powder form, okay, after drying. And when we do the separation from the filter press, it would be with 40-50% solids. And further, it would be sun dried, and then it can be used for it can be further fortified, or it can be mixed with any solid manure which is generated from the biogas plant. So, hope to answer your question.
Any question? Yeah, Aditi, can you note down the question? Is there any question from anyone?
See, the other question, I'm Anthony Conrad. You are saying a liquid substrate as a fertilizer, it can be sold as a liquid. But there are in India, there are some places where biomethanation plants are there. Plants are potentials are there, but where there is no potential for the liquid fertilizer. So in that kind of a situation, what will be the proposed solution from your end?
Well, sir, very good question. In that case, what is happening, so the present liquid fertilizer, we need to establish the market around the plant, or we need to establish the market. There is no ready market, as you rightly pointed out, but it has a very good NPK value in the liquid manure, and we need to develop that market. And your second question is, treatment options are there. We can go for a thermal treatment, or we can go for physical separation and all. But at this point in time, it is not because it calls for a lot of energy input to the system. Energy input. So the operating cost will be loaded on the final product. So, so we need to establish the market for that.
I have a question, Mr. Basavarajji. Hello. I'm from IoT Biogas, Namakkal, Tamil Nadu. See, you have referred a technology called PFR, in your presentation. Is that an industrial, it can be, replicated for an industrial biogas plant to a scale of around, say, 12 tons per day CBG production? Or it's a smaller one?
That's what No, it is available for industry scale only. and we are building two projects of producing about 10 tons per day. So one is in North India and another one in South India. A technology for industry scale only.
I have a question on coming to this technology. See, which one you suggest as operationally best and qualitatively best technology, whether it's a membrane one or amine one or a water scrubbing, which one is suitable for a industrial scale biogas plant?
So as I said, all these technologies have their own merits and limitations. But if you see chilled water scrubbing process across the globe, if you see, there are around 1,000 CBG projects or the biomethane projects in Europe and US, all put together, the countable large scale projects are around 5,000. In that, almost about, I would say, around 40 to 50% are chilled water. But membrane based is also a very good technology, which is giving very promising technology. We are also evaluating and we are also executing few projects on that. And I mean, we have to see it in a holistic way, because some processes have high capex, some have low capex, some have high opex, some have low opex. So all these things, it is not a straightforward answer to your question.
Agreed. Agreed. See, on this chilled water technology, what you are talking about, which some 5,000 plants are there in the kind of world. Water requirement will be what will be the water requirement per day? Because water becomes a scarce resource today. Is it a recyclable one, or it's required on a daily basis in thousands of KL or something like that, hundreds of KL like that?
On the capacity of the plant, it is a recyclable one.
Yeah.
It is a recyclable.
One.
Yeah, it is recyclable.
Good afternoon.
Flow rate and what you asked was the quantity. It depends on the capacity of the plant. For a typical, 10-ton plant, it would require about 50-60 meter cube of water, which can be used within the process. It can be within recycled.
Good afternoon. My name is Ashish Vaishnav. I am from Pune, company called Gangotri. You had mentioned in your press mud slide that you have about 200 tons of press mud going per day, and you are producing about 10.2 tons of CBG. But there is also an input of 115 meter cube of water. Now, is it a continuous requirement every day, or is it for the initial charge or the startup time?
It is the initial charge or the start.
I see. And how will this differ when you have paddy straw? Because you see, press mud has almost 70% moisture anyway. But what happens in a case when you have paddy straw instead of press mud? How much will be the?
It needs to be worked out. I'll get back to you, because as you said, only 10% of moisture is there along with the substrate. So
Correct.
We need a little more quantity of water in that. But we have established a process wherein we use it in a closed loop itself. So we use only minimum quantity as a top up for a freshwater requirement.
So for a 10-ton equivalent, what would be the startup quantity if it is 115 here then?
No, I'll get back to you. I don't have the numbers on top of my mind.
Okay. Thank you.
Yeah.
Baswaraji, I have one.
Okay. Have you supplied any municipal solid waste plant in anywhere in India or in the world? Only municipal solid waste.
We have not yet ventured into municipal solid waste biogas plants. Because of various reasons, so it has a lot of variabilities in the substrate. So there is no fixed amount of gas is expected. There can be a lot of, because if variation in the substrate or the feed material, there will be variation in the gas generation as well. So we don't have
That's okay. I just wondered whether you have a reference plant. There's no reference plant as such.
We don't. Yeah, no, we are not into MSW, right?
Thank you.
Basavaraji, this is Sanjay Khare. I'm from Skoda Volkswagen Pune only. So my question is, do you provide an overall consulting for this project? We want to set up a biogas plant for our own captive consumption for our own crops. So we need to have, other than technology, basically on the supply chain part of the press mat and other things, what technology we use, how will you manage the supply chain? Can we get some overall consulting from you or some other organization who can be a good consultant to us on this?
We can do that consulting. I have given my coordinates in my chat box. I would request your contact details. I'll connect to you.
I'll put a mail. I've seen that. I'll put a mail to you.
Great. Thank you.
One more question.
Please.
No, the message process. Everybody hear me? Hello. Hello.
Yeah, sir. Please go ahead.
Yeah. See, in one of your slides, you have mentioned that
Please go ahead.
In one of your slides, you have mentioned that two-stage process gives more, biogas yield than the. See, for example, from our experience. Process. Is it process? Question.
So we have lost your voice. So we have lost. Yeah, I got your question. Just to answer, we have it's an assured yield what we are giving, first of all. And the second thing is there is a scientific reason why we are giving. First thing, and the second thing is we have demonstrated it on our pilot plant, and then only we are offering.
Okay. So is there a cost advantage in the single stage reactors as well as the double stage reactors?
Cost advantage in terms of what? Of course, we'll have a better IRR if your throughput is more. No? So there will be a cost advantage.
No, I'm talking on capex with the single stage reactor.
Thank you.
Okay.
Yeah. Thank you, everyone. I think we'll keep other question on hold once the next presentation or the next training session from biodiesel will be completed. So we'll go to again a couple of questions on this topic as well, because that will be a completely question and answer session. So now I am straight away going to SP Singh Saab. He is a additional assistant vice president from Praj, and he is working with this industry since last 20 years, 27 years, and I think he is, more appropriate speaker for this. Technology related to the biodiesel, because he has almost done establishment and costing estimation and engineering of this biodiesel plants through Praj in various locations. And he knows very much into enzymatic reaction related things which is required for the biodiesel technology. So I am now straight away going to SP Singh Saab, who is a gold medalist from BTech Kanpur, IIT Kanpur. Yes, SP Singh Saab.
Okay. Thank you, sir, for giving introduction about Praj and about myself. Regarding the very interesting topic, we are going to discuss biodiesel. As you know, first time.
सिंह साहब आपको बाकी माइक को म्यूट करना पड़ेगा एक ही
हाँ now it's okay sir
it's okay
okay I think the very interesting topic now is biodiesel because of two reasons. First time you have seen that the diesel price in Delhi has exceeded petrol price. And second is basically the health issue caused by used cooking oil. And these prices, I think, just 1 second. These are the two factors more important to biodiesel, and what Praj is giving to table is a process.
ऑन रखिए बाकी को म्यूट कर दीजिए
I think yeah mute. So importance of biodiesel, basically Praj is bringing to table in India. Basically, you see there are a number of biodiesel plants. So what new Praj is bringing to the table is the enzymatic technology for producing biodiesel, because in India most of the plants are chemical catalyst based, and those has limitations, particularly in terms of effluent and moisture in the feedstock issue, and limitation of free fatty acid. So what are the problems current biodiesel industry is facing? We are bringing the solution for that. In this next few slides, I think I will be attempting to provide a solution what Praj is bringing on the table. We are going to talk about what this technology is, and what are the business drivers, and basically what is the cost of production of biodiesel for this new technology. And particularly our focus as the topic is waste to we'll be talking more on used cooking oil, but in addition to this we will also talk some other feedstocks for biodiesel. How this biodiesel is produced, I think many of you might be in the business of biodiesel. So it's a simple, basically oil, methanol is added, and with the help of catalyst, biodiesel is produced, and one byproduct in this is glycerol. This one is called trans-esterification, and second process is esterification, where free fatty acid produce biodiesel plus water under a catalyst. So the present process, basically biodiesel plants which are in India, they are using the sodium methoxide, which is a very poisonous chemical, And in addition to this, sulfuric acid is used for esterification. So to solve the problem of this kind of catalyst, we have now come out with a green catalyst that is basically enzymatic catalyst. If you see just a simple comparison between diesel and biodiesel, so you can see the formula of diesel and biodiesel. Composition, you can see basically in diesel is basically alkanes and alkenes. However, in case of biodiesel, it is 96.5% FAME, fatty acid methyl ester. Raw material diesel is crude oil, and here vegetable oil, basically used cooking oil. And in addition to this, you can use also other feedstock like tallow and PFAD, palm styrene also for making biodiesel. And if you see the emission as compared to diesel, which is 185 to 229 gram of CO2 generated per kilometer drive, here is less than 50% of this CO2 generation per kilometer drive. Blends diesel, of course, we can use as such 100%, but in biodiesel, depending upon the availability, because the biodiesel which we are guaranteeing, it meets the requirement of BS6. So depending upon availability, we can use even up to basically 100%, but Government of India has focused, depends upon the availability, up to 5% maximum. Content in diesel is 0, here it is 11%. And energy wise, this is 10,800 kilocalorie per kg, as against biodiesel is approximately 8,900 kilocalorie per kg. And these are the standards we follow for diesel and various feedstocks. In addition to used cooking oil, we can use palm oil, crude palm oil. We can use rapeseed, sunflower, jatropha, and pongia. With earlier days, we used to speak about making biodiesel, and high free fatty acids. So which are the most important components for making biodiesel is basically glycerides, triglycerides, and free fatty acids. So depending upon the composition of particularly triglycerides and free fatty acid, that will decide basically the yield of biodiesel. If the triglycerides are less, definitely the yield will be less. If some other impurities are more, that may require a pre-treatment. Little chemistry, I would not like to bore you much. So how this triglyceride and diglyceride and monoglycerides bonds are looked like. So A is triglyceride, B is basically diglyceride, and C is triglyceride, and this is a free fatty acid. So these are the just for general information about the chemical bonds. So let's come to balance. So as a thumb rule, 1 ton of triglyceride approximately will give you 1 ton of biodiesel. So if you want to find out exact value, if the triglyceride is around 890, then approximately biodiesel you will get, there is some gain due to chemical balance, 894. And we add methanol approximately 96, and this gives us the byproduct called glycerol. So triglyceride plus methanol will give you biodiesel and glycerol. This is when we are using triglyceride for making biodiesel. I told you the current process of chemical catalyst has limitation in producing biodiesel from free fatty acid. Recycle a number of times to see that 100% free fatty acids got converted to biodiesel. But enzymatic process, free fatty acid is not the limitation. Even 100% free fatty acid can be used to make the biodiesel. So that is the very plus point of enzymatic biodiesel technology. So here if you see, approximately the molecular weight of free fatty acid is 282. And again, there is some gain in the biodiesel. We get approximately 296. And methanol, when it is 282, we use around 32 parts. And here, instead of glycerol, basically we are getting the water. process in India, people are producing biodiesel. What this new technology offers, so enzymatic biotechnology, it is a multi-feed, means any feed which has a free fatty acid and triglyceride can be used for making biodiesel. So multi-feed can be used. So this can handle UCO, that is used cooking oil, PFAD, palm fatty acid distillate, palm stearine, etc. It consumes less ethanol as compared to conventional process, reason being less loss, and we have a sophisticated system of capturing any loss which is there in the conventional process for methanol. And the third is very important point, the glycerin quality in case of enzymatic biotechnology is really very good. Like a golden color glycerin you will get in the process as compared to chemical catalytic, where is almost blackish color. And of course, it's a green process. So again, little biotechnology. This is enzyme, substrates, and enzyme substrate get mixed. They carry out the reaction, and then your enzyme again comes out, and we get the biodiesel as a product. So this is a simple illustration of the working of enzyme. Brief technology, basically feedstock goes to enzymatic biodiesel process, and we can produce a Indian standard ASTM as well as European standard biodiesel. So just we'll discuss step by step. These are the feedstocks. It depends upon the feedstock quality. Pre-treatment may be required, may not be required. For example, if it is a used cooking oil, that may be blackish in color. So before going to the reaction process, we have to remove the color. So pre-treatment will be the bleaching process. So bleaching, we use the bleaching earth, and by that we will remove the color. But if the feedstock has more gums, which may hinder the process, then also we do the degumming in the pre-treatment section. After that, esterification and trans-esterification together taking place in enzymatic process, and you will be happy to know that the temperature of this reaction is very less, hardly 40 degrees centigrade as compared to high temperature process of chemical catalyst. These two processes, esterification and trans-esterification, are happening simultaneously here. And now your biodiesel and glycerol are produced. So we use some excess methanol here. So methanol is removed by flashing operation. And then we have a distillation column to recover the methanol, and it can be reused back to esterification. And after that, glycerol has more density as compared to biodiesel. We go for settling and separation process. So your through the centrifugal separator, your glycerin has come out, and biodiesel going for next step of refining. Because as per the ASTM standard and Indian standard, there is some limitation of basically free fatty acid in the final product should not be more than 0.25%. So to meet the standard, we go for neutralization and washing process, where we get the byproduct, soap stock and water. And after that, we are using the molecular distillation to meet the requirement of the standards. So any impurities left out, they are removed here. But before that, we remove the moisture. So we are going for a flash drying. After flash drying, we take to molecular distillation, and then we get the biodiesel, which meets the requirement of any standard of whether it is US, ASTM, Europe, as well as Indian standard. Bleaching, just now I explained कि when bleaching is applicable only when we use used cooking oil as a feedstock because of the blackish color. So bleaching diatomaceous earth we will be taking, and here bleaching earth quantity will be approximately 1% of the feedstock, and residence time will be around 1 hour. And after the reaction takes place, we remove this bleaching earth by pressure lift filters, and our process ensures that the loss of any oil through this bleaching earth is minimum, lesser than whatever the technology is available in the market. This is a simple block diagram of the bleaching section where bleaching earth is added here, and reaction is carried out, and then these are the pressure lift filters where the bleaching earth goes out and bleached oil goes to the next section. Now next section is basically the main heart of the section, that is trans-esterification and esterification. So this uses enzymatic catalyst. And trans-esterification, as I discussed in the chemical balance, that basically triglycerides are converted to fatty acid methyl ester, and some pH is to be maintained. pH of the reactors are basically approximately 5.5 to 6, and enzymes acts in presence of some moisture. So as against the conventional process, we need not to worry about the moisture present in the oil, because in fact, if the moisture is not there, maybe sometime we have to add the water so that the enzymatic activity is better in presence of moisture. Enzyme quantity is approximately 0.25 to 0.3% of the feedstock quantity. And typically we add 20% of methanol, which we will recover after when biodiesel is produced. And reaction time is approximately 24 to 30. We can use simple mild still agitated reactors. So cost-wise also it will not be very high. Desired acid value as per the standard requirement, we can achieve here, and if not, then we can achieve the same in neutralization and washing section. Just to summarize the basically reactor process, pH is 5 to 6, temperature is 40 to 43, time is approximately 24 to 30, enzyme loading is 0.3%, methanol we add approximately 20%, and water, if it is not there in the feedstock, we maintain it about approximately 2%. This reactor will be simple agitated, mild distill will also do, and basically in the international market, if you are using for PFAD and palm styrene, better we can have a stainless steel reactor. This is a typical flow sheet of the reaction part of the process. We have 4 reactors, and it is basically almost we make the cycle in such a way that this is a continuous process. So from one section, feed is coming and continuously feed is going out from the system. These are additive tanks, and coil is required to maintain the temperature, and these are the agitators, and recirculation pumps are there. So this is the typical reaction part. The flashing process, as we discussed during block diagram discussion point there, flashing is used basically to remove the methanol. So here we are engineering the system in such a way that the loss of methanol is minimum. And after flashing, we use the methanol recovery system where methanol is concentrated back to the whatever requirement is there and recycled back to the system. So now our process, basically we get the mixture of biodiesel and glycerin, and free methanol, whatever methanol is there, that is recovered. A typical flow sheet of methanol recovery system where we flashed methanol is taken to this distillation column, where we are using tray type of distillation column, where dilute methanol is concentrated back to more than 98-99% concentration, and this methanol which is recovered here can be used back to the process again. This is about the glycerin separation. This process separates glycerin from crude biodiesel. And if you see the color, enzymatic process produces almost golden color of glycerin as against the conventional process where almost it is blackish in color due to use of sulfuric acid and other chemical catalysts. So this is also very, you can very well produce the pharma grade glycerin when you are using the enzymatic process. Our glycerin separator, to have a better recovery and better purification, we generally prefer to have a centrifuges. However, gravity settlers can be also used, but centrifuge is preferred with reference to better separation efficiency. Neutralization section is the next. This only part of this section is to meet the requirement of standards, particularly free fatty acid in the final product, which should not be more than 0.25%. So now your crude biodiesel is prepared, which is heated up to 80 to 85 degrees centigrade. And to neutralize the excess free fatty acid, we add NOH. And because of NOH addition, some soap is formed, which is removed as a soap stock by centrifuge, by use of centrifuge. And then any soap is, whatever is traces, anything left out, we use the washing centrifuge so that there is no traces of any soap in the final biodiesel product. So this is a neutralization section where these are the reactors for reaction of NaOH with the crude biodiesel, and this is the centrifuge which remove the soap stock, and less than 0.25% free fatty acid with biodiesel is taken to the next section, that is washing section. Washing section, residual soap up to 600 ppm remained in the neutralized frame is again washed by water, and then again we use the centrifuge to remove this. So another centrifuge you use so that there is no soap traces in the biodiesel. Now next is the molecular distillation process to meet the standards of ASTM and European standard. But before that, moisture removal is better because we have washed with the water. So we go for flashing operation under vacuum. So when the moisture is removed, we take to the molecular distillation. This molecular distillation can be optional depending upon the type of biodiesel you require. So if you want to meet the standards of ASTM European grade, it is must. But if you want to produce a diesel for DG set, etc., this can be optional. Distillation is carried out at very high vacuum. Generally 1 tar is the absolute pressure. And here the impurity separation is very good because as we know that when we apply the high vacuum, relative volatility of the impure component with the desired product is very, very high. So separation is much, much better as compared to simple distillation. Molecular distillation unit looks like this, where short, we also call it a short path because we don't allow the long path distillation. It is short path distillation. So now your biodiesel is ready, which is meeting the requirement of standards. So just to summarize here, as far as the technical part is concerned, process technology has a feedstock flexibility, lower energy requirement, moisture tolerant, eco-friendly, high quality glycerin, and there is a less unit operations, not much recycling operations, and it's a clean process. And it is total continuous process. Efficiency, basically process efficiency depends upon how much triglycerides you have. So minimum efficiency we offer 90%. So 90% of feedstock you will get the biodiesel. And what are the losses? I will say losses means byproduct where it rest of 10% goes. So bleaching earth approximately 0.5%. Some goes with the glycerol. Some is in the soap stock. So out of 100, 90% minimum will be the biodiesel production. These are the standards: Indian standard 15607, ASTM 6751, and European standard 14214. This just Indian standard, I would like to show you the main important point. 96.5 means your FAME, that is fatty acid methyl ester, should be minimum 96.5 in the biodiesel. So our process guarantees, in fact, more than this. If you come to ASTM and European standards, so again here we can see the comparison about the cetane number and density and alcohol content, whatever is allowed, water content maximum 500 ppm is allowed, and this I was talking acid value. Now 0.5% acid value correspond to 0.25% free fatty acid. So that's why this is very, very critical in the process to achieve it. And this we are guaranteeing that in our process, the biodiesel will meet the requirement of acid value, which will be less than 0.5. And these are the other parameters of ASTM and European and Indian standard. Coming to the layout of biodiesel, we have a flammable section and non-flammable section in the process. Methanol storage, esterification, and methanol recovery system will come under flammable section, and non-flammable section will be the raw material storage, glycerol separation, neutralization and washing, and molecular distillation. So these will be non-flammable section. And then the product storage, soap stock and residue storage, and finals. Coming to business drivers, because technology also should talk about the business. So we see the volatility in crude oil, and as I started with the note that first time in Delhi, diesel rate has gone more than petrol. So definitely this is giving a good opportunity for the biodiesel process. And government has a certain policy made in place, like these are use of used cooking oil. FSSAI has announced on August 10, 2018 that there are various locations, companies are formed to collect the used cooking oil for making the biodiesel, particularly health issue. Because if used cooking oil gets circulated in the market, we suffer from various health issues. And as per the FSSAI, around 3 million tons of UCO will be available when these collection centers are in place. Basically pre-COVID, because now we are during COVID-19 and post-COVID, the price by the oil marketing companies was fixed 51 rupees a liter. They will buy it when the biodiesel is produced from used cooking oil. But looking at the present rate of diesel, this need to be revised with present diesel price. And oil marketing company says they will increase the price 3 to 4% every year. And pricing will be again based on the situations, it will be updated from time to time. So as per the oil marketing companies, they will require the biodiesel meeting IS 15607 standard. And they will also trace that the biodiesel which is supplied to the oil marketing companies, it's preferably it should be from used cooking oil. That is also we say as a waste oil. What oil marketing companies and FSSAI has decided, basically they have decided two business models: collection, aggregation, and conversion of biodiesel. So UCO collection from restaurants, hotel, certification by FSSAI, they will certify it, and for not allowing any misuse, we will add some denaturant in the used cooking oil. It will go for biodiesel production, and then transportation by tanker to oil marketing companies' installation, and then retailing and branding will be done by the OMCs. Second business model is collection, aggregation, and pre-treatment by an intermediary and supply of a specific quality of UCO for conversion. So here, UCO collection from restaurants and hotel, collector trucks, cans, etc. These will go to aggregators. It will go to biodiesel, and then it will go to OMCs. They will purchase it. So these are the government initiative. Used cooking oil will have multiple, basically, these are the guidelines. Before that, I will come to health issue. Used cooking oil, some malpractices you might have heard. And if that oil we reuse for our food, then this can lead to liver problem, liver disease, blood pressure, and other diseases. That's why the government is now made a policy that these basically waste oil need to be collected by collection agencies, and then it should be denatured, and then biodiesel produced, and then OMCs will lift up the biodiesel. So, policy intervention, basically collection is the issue of the UCO. So there should be organized sector for collection, certification of UCO, stopping UCO entering into the food chain because health issue, denaturing UCO after permissible use, aggregation of UCO, and traceability, assurance, and certification that biodiesel is produced from UCO, and quality of biodiesel from UCO meeting the standard requirement. This was about the business part and technical part. Now I'm coming to, at the end of the presentation, basically the sensitivity analysis, that the cost of production of biodiesel. So this is the variable cost of production. I have taken the UCO, methanol, and enzyme cost, bleaching earth, and power requirement, and thermic fluid heater is also required in biodiesel plant because you know that the boiling point of oil is 380 degrees centigrade, 380. So we cannot use steam for distillation. So that's why we have a combination of steam and thermic fluid heater. So if you see here, if you give the credit of glycerol, because glycerol is a byproduct, so generally around 8 rupees is the cost of production for producing the biodiesel of ASTM or European or Indian standard. So we are now at the end of the session, and we are open for your questions.
Yes, thank you. Thank you, Singh Sam. Thank you very much. Yes, I'm now opening this session for the question and answer. So straight away we will go to question related to this presentation immediately for biodiesel, and then we'll go for question which is from the previous presentation of the previous session. So right now for biodiesel, any question? Any question? I think I'm unable to hear anyone is Raman?
Someone has asked, can you information on the financial aspects as economic viability of the project?
Yeah, I think one chat box has come about the economical viability of the project. So see, current diesel price is going on around 80 rupees a liter. And if you take the tallow or any other waste oil, 40 rupees a liter. So 40 rupees a liter and 8 rupees is the cost of production. So 48 rupees. And if you take the GST of approximately 12%, so X works comes to around 50 rupees approximately. So I think looking at the 80 rupees diesel and you are producing biodiesel at 48 to 50, so payback period will be definitely attractive and it will be around 2 to 3 years. Yeah. One more just.
Cost of the methanol is 6,111 for 1 kg of methanol. PEA. Can you please clarify?
I think, see here, yeah, cost of methanol, basically, this value I have given for a capacity of 50,000 kg per day of biodiesel. So for 50,000, it is the 611 kg, and after that we converted to per liter basis. So this 611 is for 50,000 of biodiesel per day. So after that we converted to per liter and per kg basis. I think this answers that question.
Minimum viable.
Yeah, we have a question. What is the cost of project in minimum viable capacity?
Yeah, that's a very interesting question, and I will give you some ballpark figure as a thumb rule. So, you know, I told you in India, plant and machinery is basically in carbon steel mostly, except methanol recovery system in stainless steel. So in India, plant and machinery as a thumb rule is 0.15 crore per 1,000 liters of biodiesel per day. So let's say you are producing 50,000 liters biodiesel per day. 50 into 0.15. The plant and machinery will be approximately 7.5 crore. And in addition to this, you have a utilities, land development. So that factor is 0.25 if you take total. So along with the plant and machinery, utilities and land development, the factor is 0.25 crore per 1,000 liter of biodiesel per day. So you can just multiply with your kiloliters per day, you will get the approximately investment required. So for 50 KLPD, 50 into 0.25, that is approximately 12.5 crore. If you want to go for complete SS plant, stainless steel, which is not common in India, but in European country, mostly the plant is in stainless steel. They are definitely, as you know, stainless steel is 5 times costly than mild steel. So cost the will go to 0.75. To 0.75 into 50, it may go to higher than a carbon steel. But looking at India, the factor total plant 0.25 crore per 1,000 liters of biodiesel per day.
Okay, so what is the minimum viable capacity? Okay.
Actually, yeah, I will answer this question, but before that, just I would like to share that one plant, this new technology, enzymatic technology base, we are executing. Execution is near Kanpur, and they have selected the capacity 50,000 per day, means 50 KLPD we say. So that project is viable, and minimum I will say you should go to 10 KLPD, because below 10 KLPD, if you go for molecular distillation, methanol recovery system, distillation column based, then it becomes unviable. Then we have to go for the crude way of going. So my answer is minimum capacity is 10,000 liters a day. And after 10,000 liters per day, it is very much viable.
Okay, okay, right. So any subsidies on this plant?
As of now, only oil marketing companies say that whatever you produce, they will purchase, but bankers are ready to finance.
Okay,
subsidy, at the moment, government has not given any. Yeah.
Okay, okay. So contract with OMC will be through some tender, or it is a regular? They
have already floated a tender. I think in February, around crores of liters of biodiesel. So they go via tender, and they only check the quality, and if the quality meets their parameter, they will buy it.
Okay, okay. Any and other than OMC, how one can sell that if it's some because going through a tender, it is not always possible to get the tender. Then how people will sell that?
Yeah, that's a very good question. In fact, other than OMC, you know, if you have your there are many uses of biodiesel, particularly DG sets and other uses, tractors and other things. And there, I think you need not to go to OMC. You can directly sell to the end users.
Okay, okay. And what is the difference between normal diesel and biodiesel in case of quality? Because I have seen both the pumps together, but there is no rush on biodiesel pump and there is a very much rush on normal diesel pump. So as a user point of view, what is the difference?
Yeah. So if you see my first slide, I started with the so if you see here, almost if you see the environment wise, in fact, biodiesel is less polluting as compared to diesel. So I think education is required for our country people that when you use the biodiesel, we are not polluting the atmosphere. So as education goes forward, I think people switch from diesel to biodiesel.
Okay.
The main constraint is availability of raw material. Because at the moment, government is stressing collection centers of used cooking oil. So if the feed stock is available, I think people will go for biodiesel.
I think there is a question from some Mr. Chajed, Vardhaman Chajed. Can we directly use this biodiesel into vehicle?
Now, if you go as per the government guideline, because they have calculated how much raw material is available, so they are putting the number 5%, but as technology point of view, there is no constraint. In fact, in the Europe and other parts of the world, US and Europe, have a scheme of BD 100. 100% biodiesel can directly be used in the vehicle. So technology point of view, no issue in directly using in our vehicles.
Okay. So is there any damage to engine or is there any modification needed to the engine for using this biodiesel? I think that is the main question.
In fact,
many
biodiesel. Yeah. Actually, that question also I heard earlier for even ethanol also mixing with the petrol. But in case of biodiesel, acidic corrosive as compared to diesel. So in case of biodiesel, this is not.
Okay. So can it be used in passenger buses? There is a question from Mr. Benur.
Yeah, in fact, if you see long back, 8 to 10 years before, we had a Jetrofa in the market. Lot of news. If you throw Jetrofa anywhere, it will grow and we can produce the diesel. During that time, even in Pune, buses experiment was done on biodiesel, and they were running perfectly all right.
Okay, okay. So there is another question from Rajesh Mundraji. What is the difference in process of Praj Industries versus Clarion of Germany?
Okay. Basically, Clarion and others, as I told you, 2-3 processes are very common. One is a chemical catalyst base, and one is supercritical process. So supercritical process is basically that is very high pressure and high temperature process. But there the reaction time is less because of the high temperature and high pressure. So that is basically theirs is the supercritical and chemical catalyst. However, Praj process is total green process, that is enzymatic.
Okay. Okay. So any further question? I am not seeing any question on chat now. So anybody want to raise the hand? Please move ahead. I think there is no raised hands. Any question for earlier session, biogas? What is the progress of OMC giving permission to use biodiesel?
Yeah, OMCs has already given permission, and they have floated the tender also that you can sell biodiesel to them. And what they are saying, because of the health issue, that preferably biodiesel should be from the used cooking oil. So if you have a biodiesel, if it meets the standard, you can approach to oil marketing company. In fact, the last 2 slides which I did, I have taken from the presentation of Indian Oil, basically DGM, who had come to Praj, and they shared how Indian Oil has planned for the purchase of biodiesel.
Okay. I think another, they have some concern on rubber parts, on their rubber parts. Is there any situation like this?
Yeah, as I told you, yeah, there is a fear in the mind of the people. It started from the biofuel alcohol and also in the mind of the people for biodiesel. But as per the experience and the use of biodiesel in European country and US, this is not the issue as far as biodiesel is concerned.
Okay, okay. Oh, one simple question. So can I run my existing car with this biodiesel? Any issues?
Yeah, in fact, unofficially, I will say, I just had been to Rajasthan, one of the plant I had gone to visit, and the owner has said to me he's running his Audi car directly using the biodiesel produced from this plant.
Okay, very good. Okay, so that's very good. I mean, it's a matter of awareness then.
And availability of raw material.
Okay, okay. So any other, I mean, any raw material other than this UCO, what is the potential feedstock you can see in the country other than UCO?
I said with you, we are executing one project near Kanpur, and Kanpur city has a lot of tanneries.
Yeah, yeah, right.
So there is a lot of tallow, means that is animal fat. A lot of tallow. Yeah. So the owner of that project, they said they will prefer to produce biodiesel from tallow, and they are talking to oil marketing companies. If I produce from tallow, and they have a lot of petrol pumps also. They think can we mix it in our plant also based on your guideline. So discussion is with the OMCs if they allow the mixing of diesel and biodiesel in the biodiesel plant itself.
Okay, okay, okay. That's great. I think I'm not seeing any raised hand or any chat in the box, but I have one question related to this feedstock. Recently in Maharashtra, we had one last year. We had one MOU with Australian company. They are ready to produce BD100 with bamboo. So, is it possible with Indian technology like Praj to use biomass as one of the feedstock for manufacturing biodiesel?
Okay, what just I'd like to add here, they say biodiesel, they say renewable diesel, renewable diesel. So that is also called drop-in fuels. So
Right.
biomass can be used to produce the renewable diesel by basically gasification process.
Okay.
Yeah. So this enzymatic process use the raw material as a oil, vegetable oil or used oil, but there is a process available which will produce the renewable diesel instead of the biodiesel from biomass.
Okay. So, is there any plant or any pilot you are doing anywhere in the country or anywhere in the world of such kind?
Next step from moving from biodiesel to renewable diesel, and we are in discussion with various our counterparts that from mass to renewable diesel technology maybe
So
in
I'm why I am asking, because I am one of the member for National Biomission Mission Executive Committee member for Maharashtra. So we have one grant available. Option available to put up one pilot plant from bamboo to biodiesel or the energy. So no one has applied for so far. So maybe Praj can apply and go ahead with the pilot.
Okay, that's a very good information and suggestion, and we will internally discuss and come back to you. Yeah.
Okay. Right.
I think there is one more chat.
Yes. Is the catalyst enzyme easily available in the market or imported?
Actually, there is a leading company called Enzyme, and they are ensuring that this enzyme will be available to any company, and there will be no scarcity of availability of enzyme. So they are guaranteeing the availability of enzyme in India. And we can also have an agreement with them that when they start producing biodiesel, they will not be able to increase the price of enzyme. So we can have also price agreement with them about the cost of enzyme.
So there is one question. Okay, so there is one question. Where and when can we see the plant in working?
As I told you, our first plant is coming near Kanpur, and engineering is done. Now civil work is going on, and plant all equipments are under manufacturing stage. Hopefully by December of this year, because project got delayed due to COVID-19. So engineering is completed. Now manufacturing has started. So I think by December, our plant capacity of 50,000 liters per day will be ready.
Okay. So any pilot plant or anything which is available to see?
Pilot plant, like we have done the experiment bench scale and pilot scale at our R&D center. And after that, basically client for whom we are building up the plant, they have we have shared the information that such plants are already now in the United States. So with that confidence, have already gone with the large scale plant. So what I mean say how in the lab and small pilot scale, if anybody is interested, we can show the process at our R&D center.
Okay, right, perfect. Any question, Mr. Sanjay Ambure? Hello. Any questions, Santosh Gondelkar ji? I think there. I think there is no question at this moment from participant. I think everyone is hungry and want to break away for the lunch time. So before that, we are closing the. Yeah. Before going to lunch and closing this session, I would like to go to Mr. Venugopal from Praj Industries for the concluding remarks and closing remarks for this session. Before that, I would like to thank all the participants from IoT, Indian Oil Tanking, especially Mr. Atul Karateji and team from South India. They are our one of the corporate member of IFGE and they have participated with the team from South India. So they are having already existing biogas plant, running biogas plant, which is inaugurated by Honorable Prime Minister last month, I think, virtually. So they are the team from that plant. So they were also participant from the today's participant for this training. So now I would like to go Mr. Venugopal Nair for the concluding and closing remark for the closing. Venugopalji.
Thank you very much for this opportunity. IFG, as most of the people must be aware that we are working towards green energy in whichever form it is available, which is the need of the country today. And when this opportunity came up, and since our chairman sir is the president of IFG also, we had to take this initiative forward, and this training program, which is more related to bioenergy, where you have bioethanol, which will be presented tomorrow, and today we had biogas and biodiesel. So we had our best of the best experienced senior most people who are the ones who are experts nationally also, and who have faced situations and various what you call troubleshooting this thing also in the field. They were the right people to come here and present to the people who are actually participating as delegates today. I'm sure they must have definitely benefited from this experience, and if they have any queries or any further clarifications which they need later on also, they can route through IFG all those queries, and we will certainly look at all those queries and try to satisfy all of them. And it will be a great opportunity, and we look forward to IFG conducting such programs again and again for the benefit of the stakeholders across the country. And Praj is always there to support with the faculties from various different bioenergy, biomobility, bioeconomy fields. Thank you so much once again. God bless you all. Thank you.
Yeah, thank you, Venugopalji. Raman, can you close down the presenting screen? Yeah, SP Singh sir, आपको screen down करना पड़ेगा. Thank you very much, everyone, for today's participation, and I hope you all will be joining tomorrow for the next session on time. Today we have started a little bit late, so I hope tomorrow we'll be joining on time. And all the presenter, I will like to request all the presenter also tomorrow if there are any questions. So you will also be. It will be good if you can join a little later at the question answer session of the tomorrow. So if there is any question from the participant, we can answer that also, or maybe someone can be deputed from Praj to answer this question or queries from the participant tomorrow also. After the all the session of the tomorrow. Thank you very much. Thank you very much, IoT. Thank you very much, Agrovision Corporation. Thank you very much, Praj Industries. Thank you very much, PRSPL. And thank you very much, all the participants, for joining us today. See you tomorrow in the morning again. Thank you.
Thank you.
Yeah, Raman, now you can close. Yeah, Aditi. Yeah, now you can close the session. Thank you, Venugopalji.
Thank you. Right, bye.
Thank you, sir.
Yeah, thank you.
Thank you. Thank you, SP. Thank you, Basil.
Thank you.
Yeah.
Yes, sir. Thank you, sir.
Yeah, thank you. Yeah, Aditi, Raman, can you close the session?
Okay, sir.
Yeah. Yes, Aditi, you can close the session now. I think almost everyone is leaving.